So we have a guiding question that is going to help us calculate the composition, calculate the theoretical air supply per kilogram of fuel and mass of the products of combustion per kilogram of the fuel, given the composition by mass. So we are told that the fuel has the following composition by mass. We have carbon which is 86 kilograms, 86%. Then hydrogen is 11.75%. Oxygen is 2.25%. If I add these two, this is going to be 13 plus this to become 14. So 14 plus 86 should add up to 100. So calculate the theoretical air supply per kilogram of fuel and mass of the products per kilogram of fuel. So the beginning point always is to understand the constituents of the fuel, and then carry out the chemical reactions, look at the products, and then those are the equations that are going to help us look at the contribution by each. Like, for example, how much did the carbon consume for oxygen? How much did the hydrogen consume on oxygen? And then what was the impact? Of course, we have also this other oxygen inside the mixture. That means this is not going to, we are not, if we are supplying oxygen, then we are going to be supplying it in excess. With this less. In other words, if it is 20% of oxygen, then we shall subtract there the 2.25%. That's what I'm trying to mean. So we begin with combustion reactions. The combustion reactions will have, first of all, carbon plus oxygen. So this oxygen helps to burn this carbon, produce carbon dioxide. If we are talking about complete combustion. So this is composition by mass, and therefore whatever we are doing is going to be by mass. This is going to be 12 kilograms of carbon. This is 32 kilograms of oxygen. We have to remember that carbon always is 12, oxygen is 16, and the hydrogen is equal to 1. So if I'm doing this, you shouldn't get worried where we are getting 12. So this is 12 kilograms of carbon. This is oxygen, which is 16 times 2. We get 32, giving us 12 plus 32, which is 44 kilograms. What does that mean? It means 1 kilogram, if I divide both sides by 12, I will have 32 out of 12 kilograms per kilogram of fuel. Then I will have 44 kilograms out of 12, 44 out of 12 per kilograms per kilogram of the fuel. So that will tell you that here, what will this be if maybe we cancel? Okay, even if we don't cancel, we shall cancel it as we proceed. So what is the mass of carbon? The mass of carbon is 0.86 kilograms. So if 1 kilogram of carbon required 32 out of 12 kilograms of oxygen, how about if we had 0.86? So we are saying 1 kilogram. Okay, let me write it down here. So 1 kilogram of carbon required 32 out of 12 kilograms of oxygen. What about 0.86 kilograms, which is given in the question? So this will be 32 out of 12 times 0.86. And this would give us, we have 32 divided by 12, we multiply by 0.86. So this gives us 2.293 kilograms of oxygen. Why are we calculating oxygen? Because we are told to calculate the theoretical air supply. So oxygen is related to air, because once we get the amount of oxygen that was required or that was consumed, then we can relate it with how much air was supplied, and then we can have we will have been able to answer this particular problem. Then we need also to talk about the reaction of hydrogen. Okay, so hydrogen plus oxygen gives us what? Gives us water. So if we balance, we can put our half here. So 2 kilograms of hydrogen are required 16 kilograms of oxygen to give this is 18 kilograms of water. So that means what is the amount of hydrogen available in the fuel? It is 11.75. So that means oxygen required for the reaction will equal to 16 out of 2 times 0.1175. So we have 8 times 0.1175, and this gives us 0.94 kilograms. So we need to total what else did combust or did burn to produce energy? Nothing. Oxygen is present in the fuel, so we are just going to subtract. So total oxygen required is equal to 0.94 plus 2.293. So plus 0.94. So this gives us 3.233 kilograms. So net oxygen required will equal to oxygen needed, or the oxygen required, minus oxygen available. And therefore, that oxygen is going to be 3.233 minus 0. So 2.25 divided by 100, so minus 0.0225. So we take away that value, 3.233, and the net oxygen,
close to 3.008.
okay, will be 3.2105. I had 3.233 minus 0.94. I mean 3.233 minus 0.0225. So I get this value. Now, we have to recall that 23 kilograms, okay, 23 kilograms of oxygen are present in 100 kilograms of air. So what about 1 kilogram? 1 kilogram will be present in 100 divided by 23 kilograms of air. Then what about this 3.2105 kilograms? Will be 100 out of 23. So times 3.2105, and finally our answer should give us air. Air should be 13.96 kilograms. So this is the mass of air required. So that is the mass of air required. Now the other question says we want the mass of products of combustion per kilogram of the fuel. So the mass of the products of combustion. So we need to look at, for example, the mass of carbon dioxide. The mass of carbon dioxide is here, 44 divided by 12 times how much of carbon was burnt, which is 0.86. Then we add there, for example, another product which is vapor. So how much of vapor was produced per kilogram of hydrogen? This will be 18 divided by 2, again times 0.1175. So this is what we should do. We go down and talk about mass of the products of of combustion. So mass of products of combustion. So one, we have water, okay? We have the water vapor or liquid. It could be liquid or vapor. And then we also have carbon dioxide. So from the equations of the reactions, it is seen that 44 out of 12 44 out of 12 kilograms of carbon dioxide per kilogram of fuel is produced. Okay, so that means 1 kilogram of fuel is giving us 44. Okay, maybe we need to reshape this. This is not specifically on the whole of fuel, but 1 kilogram of carbon. Okay, so 1 kilogram of carbon is the one that is giving you 44 out of 12 kilograms of carbon dioxide. So what we do, 1 kilogram of carbon is giving us 44 kilograms of carbon dioxide. What about 0.86 kilograms? What would they produce? 44 out of 12 times 0.86 kilograms of carbon dioxide.
Is equal to 3.153.
Okay, is equal to
3.153 card.
Okay, this is kilograms of carbon dioxide. Then we also need to look at the other one is hydrogen producing water. So 2 kilograms of hydrogen also gives 18 kilograms of water. So what about the 0.1175 kilograms of hydrogen? Will give 18 out of 2 times 0.1175. So that is 9 times 0.1175, and this gives us 1.0575 kilograms. So total of the combustion products will equal to 3.1533 plus 1.0575 plus 3.1533. So finally, the products of combustion will equal to 4.2108 kilograms. Will be 4.2108 kilograms of products per kilogram of fuel. So that's how we can answer that problem. And the mass, the theoretical air supply that we produced was 13.96 kilograms, and the mass of products that were produced per kilogram of the fuel will be 4.2108 kilograms.